I'm Anil Kumar. In this video, we'll discuss volume of composite objects. Let me begin by classifying objects into three categories, or rather two. You can say objects could be kind of prisms, or it could be pyramids. What we are doing here is we are making composite objects or combination. Right. So that becomes composite objects. So if we understand the basic objects, it'll be easier for us to get to the combination. Normally, when we say volume, then volume in general will be equal to area of base times height. For a pyramid, normally volume will be equal to 1/3 of area of base times height. Right, so most of the cases. Right, so let me put a star here. Okay, in general. Now let's take few objects. Let's take, for example, if my object is a cube, then area of the base is side squared, and let's say height or length is shown like this. In that case, clearly, if the dimensions are, let us say each side is S and height is also S, then we know that this volume is equal to side cube. Now if I take a shape which is a rectangular prism, then the dimensions will be different, right? So we are talking about now, let me make a smaller one. Okay, so rectangular prism. Okay, let's bring it down. Kind of like this. Okay, this is not so good, but still. Let's say we have something like this, where we're talking about length, width, and height. So in this case, as you know, the volume will be equal to what? Let me write here. Length times width gives you area of the base times height, right? So just multiply all three of them. The other basic shape which we have is a sphere. Right? So think about this as a sphere, right? A ball. Now in this case, volume is equal to 4/3 pi r cube, where r is the radius. So these are the basic shapes and the formulas given to you. As far as the pyramids is concerned, we normally assume that let's take a prism could also be like a cylinder. So let me make a sketch here for a pyramid. Let's say we have a square base pyramid. Right, so with the height kind of like this, right? So let me just join them. In this, if the height is h, let's say height is h, and let me just generalize it. Instead of square, let me take this as length and width. In that case, the volume will be 1/3 of length times width times height. So basically area of the base, whatever it is, times height, and do it 1/3. In general, this formula works. You can also take example of a cone, which is kind of a special case. Now, the volume here is 1/3 of area of the base is pi r square times height, right? So where this is radius r and the height is this. So that is how we actually get the volume formula. So I hope the basic is clear to you, correct? Now with that, we'll now begin with the combination of objects. So I'll take up elaborate examples on combination. So to begin with, let's take a combination with, let's say, a prism here. And on top of it, we can place a pyramid, right? So on top of it, let's place a pyramid. If I provide you with the dimensions, let's say this is 10 and this is 5, the height is for the prism is 4, and this top is, let us say 6, right? Let's say all are in meters. In that case, the total volume will be equal to volume of the prism, right? Let's call it prism plus volume of the triangular pyramid with rectangular base. Okay, so these two volumes. So now the volume of the base will be 10 times 5 times 4, and to this we will add volume of the prism, the combination, which is 1/3 of area of the base, which is 10 times 5 times the height, which is 6 meters, right? So all this combination will give you the answer. So let's use the calculator to calculate this. So we have 10 times 5 times 4 plus, let's write 10 times 5 times 6 divided by 3 equals to 300. And cubic meters or meter cube is going to be the answer, right? So I hope that makes sense. So when we talk about combination of objects and their volume, this is how we can find it. So I hope the basic concepts are clear to you. Now we'll take up some questions to practice. Now let's take a few practice examples. We'll begin with a cylinder, right? So I didn't give you the formula for cylinder earlier. Here is one. Let's say for this cylinder we have diameter of 10 centimeters. And the height of this cylinder is 30 centimeters. You need to find volume. You can always pause the video, answer the question. Now volume is area of base times height. The base is circular, right? So area of base is pi r square and times height h. That becomes the formula. So volume V for a cylinder is pi r square h. Right? Now in our case, we are given diameter. So radius r is equal to half of diameter. So radius in our case is half of 10, which is 5. And therefore the volume is pi, which could be written as 3.14. Radius is 5 square, times height, which is 30. Units will be centimeter cube, right? So we can use the calculator to find this answer. So 3.14 I'm using for pi times 5 square times 30 gives us a volume of 2355 centimeter cube. Now at this stage, it may be important for some to write the answer in liters, right? So here is a conversion. We could write this as 2.355 liters, right? So it is important to understand that 1000 cc or centimeter cube is equal to 1 liter, right? So this conversion of unit is also very important when you are working with volume. Now here is a question for you. Question is that if I have a right circular cone inscribed in this, so that is my cone now, okay? I need to find volume of cone inscribed in the cylinder. You can pause the video, answer this question. The answer is what? Volume of cone is 1/3 volume of cylinder, right? So just do 1/3 of this value. You'll get the volume of cone, correct? So the answer will be, you can divide 2355 by 3 to get the answer 785. So in this case, volume of cone is going to be 785 centimeter cube. Okay, so that is how cone and cylinder are related. So I hope that really helps you to see both in one picture. So volume of cone is 1/3 the volume of cylinder. Okay, so volume of cone, we can write a formula. Let me write here, volume of cone equals to 1/3 of pi r square h. Is that clear? So that is how we can calculate the volume of a cone inscribed in a cylinder also. I hope that makes sense. Now I'll take up another composite object. We will have a cylindrical object here, and on top of this we'll add a hemisphere like a dome, right? So that becomes a 3D object for us. Now what we are given in this case is the radius of this cylinder. Let's take this as 5 centimeters. Let's take 5 meters, and the height as, let it be 20 meters. Now you need to find volume of this composite shape. So in this case, you'll add volume of cylinder to the volume of hemisphere. Correct? Volume of cylinder is pi r square h, and volume of hemisphere will be half of the volume of the sphere, which is 4/3 pi r cube. So that becomes your basic formula. So the total volume can now be written as combination of these. So it will be pi times r square, which is 5 square, height 20, plus this could be simplified. You could write this as 2 over 3 pi r cube. So we'll write this as 2 over 3 times pi, radius cube, 5 cube. We can use the calculator to find this answer, right? Some of you can also simplify this a bit and then get the answer, okay? So let's calculate it straight. So we'll use 3.14 for our calculations for pi value times 5 square times 20 plus 2 times 3.14 times 5 cube divided by 3 equals to. In some computers, calculators, you may use brackets, right? So it is 1831.66. We can round this to 1832 meter cube. So that becomes a combination of cylinder with a hemisphere. Now this kind of structure is called silo and is used for storing grains, right? Let's take one more example, and that will be the last example in this sequence. Now in this case, I'll take up a tent kind of a structure. Let's say, let me make a right triangle here. I mean triangle, and I'll provide you with the height of this triangle. Okay, so let's try to make this diagram. Okay. So let's say that is a tent and it is placed on some box, right? So it's placed at some higher level. Looks like a house. Okay. You need to find volume of this structure where these dimensions are, let's say 6 meters, 12 meters, height of 2 meters. This height of tent, let me take this as, we're given the height as, let's say 5 meters. And the slant height, let's take this as 7 meters. Okay. Now what is the volume of this particular structure? I'd like you to pause the video and answer. The top portion, which is triangular, we have to find area of the base, which is a triangle. Now in this triangle, important dimension to use is not 7, but this side of 6. These two are parallel and will be equal. Now if you take 7, then you may get a wrong answer, right? So here the volume is area of the base, which is half, base is 6, times height of 5. Do you see? That's the area of triangle, right? Times the length, which is 12 meters. So this portion here is area of triangle, right? We are going to multiply this area of triangle with 12 meters, which is the length of this, right? The triangular, you can say prism. That gives you the volume of the top portion. And to this, we are going to add the volume of rectangular prism, which is 6 times 12 times 2. Doesn't make sense to you, right? So this is the volume of a rectangular prism. Now you can again use the calculator and get the answer. So it is half is 0.5, let's say 0.5 times 6 times 5 times 12 plus 6 times 12 times 2 is the answer, 324 meter cube. So it is that simple. You have to basically see the combination and add volume of each as we have done in these couple of examples. I hope the strategy helps to move forward. So let's review what we have learned. We basically started with volume of different objects. Objects can be broadly divided into prisms and pyramids. Volume of basic objects is given here. For a cube, it is cube of the sides. For a rectangular prism, it is product of its dimensions. And for a ball or a sphere, it is 4 by 3 pi r cube. For pyramids, it is area of base into height as usual, but 1/3 of it. So always 1/3 of it. Well, here I wrote wrong. It should be 1/3 of pi r square h. Then we took an example with a combination of a pyramid on a prism. So if you have to find the total volume, you have to add them all. And after that, we took few more examples. Here is one combination of, it's not actually combination. We did volume of cylinder. And then from there, we derived the volume of cone, which should be 1/3 the volume of cylinder. Correct? So it's kind of important. You can now also get a question saying, what is the volume of space in between, right? That space. That'll be 2/3 volume of cylinder, right? So you can think like this when you solve questions based on volume. We also took an example on silo, which is combination of hemisphere and cylinder. And we also learned how to convert units. Now, that brings me to a question here. Now, what is 1 meter cube equals to in liters? So that is a question for you. You have to figure out what is 1 meter cube in liters. So in a way, if I have to write this answer in liters, what should it be, right? So let this be another question for you. The last example is the combination of a triangular prism over a rectangular prism, right? So we basically have a triangular prism plus rectangular prism. It was important to note that the dimension which was given as the slant length is not to be taken. Area of a triangle is what? Area of a triangle is half of base times height. Now that is critical to remember. Sometimes you might just do a mistake of taking wrong dimension into consideration. So just take care of that. So I hope with that we can wind up, and your concepts of volume should be fair enough to try some questions from your book. Thanks for watching, and if you really like and subscribe to my videos, that'd be great. All the best.